Hi everyone, welcome to another table talk. Pardon me. So today I wanted to give you a good review on my lessons learned with my build, flying, setup, that sort of thing on this FRC Foamies FA-18 Hornet, which if you follow my YouTube channel, I've already shot some flight video on it. I've had 3 awesome flight sessions and I have a total of 50 flights on it now, so I've really got it dialed in the way that I wanted it. This is my first park jet with the motor mounted in the tail, so obviously it was a learning curve for me because the other 80 plus park jets I've built, the motor has been sort of more mid-mount prop and slot type setup. So anyway, I chose this F-18 by FRC Foamies because it seemed to be, I wouldn't have to do just some minor modifications, KF4s and a couple of other things to suit how I like my park jets to fly. So the guys at FRC Foamies were very helpful in answering some of my questions up front before I got going with my build, so that helped me get started really well. Okay, so I'm just going to get right into it. This video is probably going to be a little bit lengthy, so you might want to pause it, go get yourself a beverage, preferably caffeinated, maybe even a snack. But anyway, we'll press on through because I learned a lot, and building a tail mount park jet is certainly a bit different and not overly difficult, but there are definitely some planning and thoughts that you need to have going into it that you don't necessarily need to worry about so much with a prop and slot park jet. So, okay, so pardon me. I built mine because I'm using a quad racing motor here, just a small quad racing motor. I wanted to make it a little bit smaller because sometimes with a really big park jet they can struggle a little bit, pushing that extra drag through the air. So I sort of found anywhere between 25 and 27 inches is kind of the sweet spot. So I sent these off to my printer and I was hoping they would come back as a 27-inch wingspan. I ended up with 26 3/4, but I may add some missile rails on the end there, so maybe it'll end up at 27 inches anyway. Okay, so that I do have a fairly long list of notes here, so please excuse me if I refer to those quite often, but I took the time to write these up because I didn't want to miss anything in case you could learn from my build if you decided you want to build this plane or another sort of tail mount park jet. So I built mine primarily with model plane foam grade B, except for I did use some scrap Defron for my vertical stabilizers, my elevons, and this sort of horizontal stabilizer plate that goes up inside here. My KF4 airfoils are made out of paperless Dollar Tree foam. Could you build this just with Dollar Tree foam? Yes, you probably could. I didn't really want to bother. I've got lots of MPF, and you can still get MPF here in North America. So trying to figure out where to put the paper, where to leave the paper on, take the paper off was going to be a bit complicated. So building with MPF was the way to go for me. Okay, so components, again, I'm using, this is a FRC 2306 2750 kV quad racing motor. It's one of the most powerful quad racing motors that I've used, excuse me. And I also wanted to be able to run this on, on 4S just by changing the prop. So I went with a Hobby Wing 40 amp Platinum Pro 40 amp speed controller, which can handle 3S and 4S with this motor. I went with an 8-channel receiver because initially I was going to go with maybe have the possibility of going with V-tails, so if I when I pulled up on the stick, my rudders would go inwards. After realizing how responsive it is in the pitch already, I've actually taken that mix out of my transmitter. I'm using 9-gram RC timer servos here for my elevon, and 5-gram nylon gear servos for my ailerons and rudder, and that's giving me plenty of authority. But by using these 5-gram servos, it helps me keep the weight down. Yeah, so I could probably, if I was to build it again, I would probably go just with a 6-channel receiver, and you know, just run the rudder servos with a Y harness just to save a little bit of weight. You know, maybe 5 grams, 5 to 10 grams or so. Okay, overall, it's certainly not what I would consider a beginner build. You know, I've built lots and lots of park jets. I've built a lot with foam. So I wouldn't, you know, as beautiful as it is, and you know, you might want to, if you're just getting into park jets, I'd certainly build, you know, another sort of simpler score and fold prop and slot park jet first before I jumped into this build and flying. There are some subtle differences in flying, which I'll talk about later. Some real helpful things. This 8-picture diagram, it's in black and white, but you know, if you look at it on the plans, it's in color. Oops, I got it upside down here. So it you know, logically lays out 1 through 8. I built my canopy early. That doesn't really matter. But if you follow along here, sort of 1 through 7, it gives you sort of the order that things go in. And this was really, really helpful. Another very helpful thing with the plans that I strongly encourage you to either print off or look at. This is normally color coded, so you know, all these parts here would be of different colors, and then you can see the completed airplane. This is the exploded view file which comes with your plans. So I strongly encourage you to you know, if you don't want to print it off in color to save ink on your printer, just have it available on your computer so that you can look at it. It'll also help. And the other sheet that is also very helpful, this is the info page. It's got some, you know, some good info on you know, some possible recommended motors, you know, radio setup, elevon or control surface deflection, the specs, width, length, weight, that sort of stuff. So yeah, these are very, very, very helpful. So I think, you know, if you've got some experience using these diagrams and these sheets here, again, you don't necessarily have to print them off, but I would strongly encourage you to go look at them. That would be very, very helpful. For the some of the parts, especially this top fuselage, you'll definitely want to use a good sharp blade when you cut this piece out, and then be very careful when you handle it, because there's several long pieces here which become very long and thin and sharp as you go back along there. So you'll want to use a nice sharp blade, and then be very, very careful when you handle that part so that you don't bend it or snap the pieces off. You know, otherwise, you know, just there are lots of score and fold cuts to give it the nice scale look, you know, with these scale looking rounded intakes and all that sort of stuff. So yeah, you just want to take some care and make sure you do have nice sharp blades, or replace your blades if you feel like they're starting to get dull. All right, so let's talk. I'm just going to start at the front here and just talk about some of the mods. Now, as I mentioned, I made some mods, some for, I guess, function because of how I like my park jets to be set up, and some, as I went along, I just had to make it, you know, make some modifications to get things to fit properly. So starting at the front, like I said, I did build my canopy. Normally there'd be some little bits of foam that come down here that slide in there. Because I downsized this plane, I was a bit concerned about being able to fit my battery into the battery bay here. So I cut those off and I carved a little bit out. So then what I did was I just put a little tiny chunk of popsicle stick on the front of it, and I just cut a little groove in the foam here. So that just goes in there, and then boom, on the back here, you can see I've got a magnet. So that worked out really well. I also carved, you know, making sure that I wasn't going to ruin the look of the plane. Underneath here, this piece here was quite a bit bigger. So I carved that out a little bit just to, you know, make it easier when I'm handling the battery and, you know, with my big fat sausage fingers. I did, you're not going to be able to see it, but the back of the battery, sort of the spine comes along here. Before I put this bottom piece of the fuselage here on in the front, which is one of the last pieces to go on, I started to get, even though I had done a bunch of dry fitting and testing to see how the plane was going to balance, I ended up cutting about an inch out of the spine here so that I could slide my battery back about an inch further. And I'm glad that I did, because it turned out, because of how I laid other things out, I need to have my battery pretty far back. But you know, luckily it balanced just fine, so I got lucky there. Okay. Part of this could be, and again, if you're, you know, one of the reasons that is, this motor, this quad racing motor is, you know, it's very, very powerful for its size, but it also weighs about 20 grams less than your standard, you know, sort of 2212 size motor. So because this was designed to use a 2212, you know, having 20 grams less back here on the motor does, you know, by the time you get here to the front, does make a big difference. So, you know, if you were going to play around with a lighter weight quad racing motor like that, some of these things that I'm going to talk about, you know, you want to keep those in mind so that you can fit your battery in and balance your plane okay. Okay, my KF4 airfoils, they're 40%. Whoops, 40% at the of wing root here at the cord. Basically, you know, just drawing a line in and using this as the cord, not including this leading edge root extension as part of the calculation, and 40% out here at the wingtip. I find for F-18s, more straighter wing park jets, that's a good configuration. Down below I'll have a link to a video that I made on how I work out making these, making my KF4 airfoils, and I also extended it along the leading edge root extension here, just again because that's a configuration that I've come to know and I really like. So that's what I did there. So if you're interested in doing that, like I said, please check out the video link down below, and I do a demonstration how to make KF4 airfoils. Okay, servos. I did put the my aileron and aileron servos as indicated on the plans. I don't think that I would play around with those too much more. I mean, obviously I can't really move my aileron servo back any further. I've only got about a 2.5 inch bush rod there, so leave those there. Initially I was going to put, and I actually cut the holes out here, I was going to put my rudder servos up further here, and I ended up, after playing around with the balance, I decided to move them back further. If I was to do it over again, I might actually move them almost all the way to the very front of the vertical stabilizer. Again, just because I do need to compensate for the fact my motor is 20% lighter, or 20 grams lighter than the motor that this plane was designed for. But anyway, again, I got lucky, and that ended up balancing. Okay, moving right along here. Okay, and with the scale location of the elevon, you can see here that I did run my linkage over top rather than, a lot of park jets you run them down below. So this works out really, really well. So that's how I did that there. Again, as long as you make sure that the although my bevel for my hinge is on the bottom here, as long as you make sure that the holes of the control horn are directly above the hinge line, on both sides, it's still going to work out just fine. All right, for my ailerons, I prefer a 60%, an aileron that's about 60% of the total trailing edge of the wing. So I measured. Actually, this is a fixed. This area here is fixed on the plans anyway. But I measured this this trailing edge of the wing here. The stock has it going all the way. I find I have problems with tip stalls when I use full-length ailerons. So all I did was I measured from here to here, took 60% of that, and then I just started the aileron exactly where it is on the plan. But once I measured my 60%, so that's what I ended up with, and it provides plenty plenty of roll authority. I haven't really played around with them yet as flapper-ons or spoiler-ons or anything, but that's worked out well. In the horizontal stabilizer, based on after reading through the entire thread on this plane on the RC Powers forum, I did put a 3mm carbon tube through that runs all the way through here, so that's good and strong. You know, maybe with Depron, it's not necessarily needed. This plane's only with a 2200 3S battery is only weighing about 21 ounces. So, but anyway, it's nice and strong. In my wing, I used a 4mm carbon rod, and I actually moved them back a little bit further than where they were placed on the plans. And really, that was just because I had two rods that were already cut and were the perfect size to fit. What I would probably do, here's my one in the front, in retrospect, even again to save maybe 5 or 10 grams, because carbon rod is, 4mm carbon rod is about twice as heavy as 3mm carbon tube. I would probably, in the front here, I would use a 3mm carbon tube because, you know, once it gets locked in under those KF4 airfoils, it's, you know, still going to be a super strong wing. And I've been yanking and banking this thing pretty aggressively, and I haven't seen any wing flex whatsoever. So that's worked out really well. Okay, I did need to trim my elevons just a small amount because, again, my motor is about you know, the stator is about 6 mm shorter than a 2212. What I ended up doing was I just after, you know, sort of dry fitting and figuring it all out, was I measured in about 1/4 of an inch here at this very tip, and then I just tapered. So this part here is the same. So I've just sort of tapered off, and I've actually got, now that I look at it, once it's all mounted, I've got plenty of room. I might have even been able to leave it there, but I didn't want to have any, you know, situations where the prop could potentially hit the elevons while I was flying around. So that was one mod that I had to make. I didn't bother putting on the engine nozzles. You know, there are engine nozzles to make it look a little bit more scale, you know, that you can put on the back. Because my motor again is so short, I would have had to trim these down quite a bit, and I just thought, nah, it would probably look worse than not having them, so I just didn't bother putting those on there for aesthetics. Okay, so the you know, following along on that 8-picture diagram, the vertical stabilizers were one of the very last, probably the very last thing that I put on the plane. I also found it was very handy to have these poor man's supports, you know, like you know, when I was working on the plane, I needed to flip it on its back or, you know, lay it on its front in order to work on it. These are really helpful, and, you know, just a couple of scrap pieces of 2x4 lumber. You know, obviously it's not going to flip properly because the tails are on now, but these were really helpful. So just a thought there as you're, you know, flipping the plane back and forth on its back, right side up as you're working on it. Those came in really helpful. Okay, I put my one thing about obviously a tail mount airplane is you sort of have to, you know, figure out where your electronics are going to go, your speed controller, your receiver, your servos, and all those wires before you completely bundle it up, because you've got to connect all that stuff up and make sure that it's all working before you finish putting the plane together. Otherwise, you have to cut the thing open, or, you know, maybe modify, put some sort of hatch or something in there. My speed controller, I put my speed controller on this side of the airplane, the right side of the airplane, to give a little bit more weight to help counteract torque roll. It's only a 40 amp speed controller. It's not that heavy, but it's heavier than the receiver and the wire bundle over here. I put mine, I'm just trying to see if I can see, there's a small hole here. Yeah, my ESC and my receiver is about here. And in retrospect, again, because I had such a lighter motor, I would probably move those back another inch or so back to about here somewhere. Only so that I would have a bit more flexibility up here, because the way my battery is sitting right now, I have 5 full inches of battery battery compartment here that's not being used. You know, and again, I just got lucky that my plane balances the way that it is. So, so what I would say is, you know, when you're getting ready to put these pieces all together, you know, you can put this, I put this piece on, and then you have this little panel here and this part of the nose. Those go on last after figuring out where all the electronics and stuff go. I did end up with about a 6-inch extension between my motor and my speed controller that I made, and I also have about another 6-inch extension between my speed controller and my battery, just so that originally I wanted to put my speed controller up a lot further, but the plane was just never going to balance that way. So anyway, what I would suggest is, what I did was, once this piece was on, I sort of, you know, I dry fit my servos, tape things in place, tape the motor in place, that sort of stuff, and then just run through a couple of you know, trials to sort of get an idea with your battery in there where it's going to balance, so that you can, if you have to move things around and adjust them, you can do that before you've got everything glued together, and then hopefully when you get out to fly it, it's going to balance properly on the CG without you having to carve anything apart after the fact to get your battery placed. Okay. Alright, talked about that. Okay, we're moving right along. I did need on my servos, for my rudder servo and my aileron servo on the right side of the plane here, I did need some servo extension wires. I think I just used 6 inches, 6-inch ones, long ones, because that's what I had laying around. Just to make sure, you know, you don't want miles and miles of servo wires in there, but you also don't want a situation where, you know, you're pulling your servo wire super tight and then plugging it into the receiver so that there's like no play in it, so that you know, you get flying around aggressively and your servo comes unplugged. So you know, run whatever you need to run to make sure that you can you know, have a little bit of play in your servo wires without bogging it down with a ton of weight. And then I also, there's a couple of different ways to make sure that those connections between, you know, on the servo extension wire and your servo, make sure that those stick together. I've heard of people putting some heat shrink on them. I just put a couple little dabs of hot glue on there to hold those together, and that's seems to work well. All right, so once I've already mentioned, so once I got all the electronics sort of laid out, servos installed, wires run, all that sort of stuff, motor, you know, you want to check and double check that your motor is running in the correct direction. Because once you get it all glued together, if you find out your motor's running in the wrong direction, you're either going to have to buy a prop that is designed for the opposite direction that your motor's, or to you know, like a counter-rotating prop or whatever. Hopefully you understand what I mean. Otherwise, your prop's going to be spinning in the wrong direction. So I checked and double-checked that. Servos, everything was going. I mean, obviously in my transmitter I can adjust all my servo directions and all that sort of stuff, so I wasn't too worried about that. And then, like I mentioned, put this on, put this long piece on, and then we're good to go. Pardon me. Okay, I did all my final sanding, you know, including my KF4s, all of that sort of stuff, before I put my vertical stabilizers on, just because it's easier to handle, and I didn't want to bang my stabilizers. I already had my motor installed by that point, so all I did was to make sure that none of the dust or anything got in it, especially with these quad racing motors, because this is a naked bottom, so the stator on the bottom is completely open to the air. I just put a little plastic sandwich bag over top it and zip tied it to keep any dust out of there, so that worked out really well, obviously with the prop off. Okay, I then installed, because I needed to have the airplane flipped on its back, I then installed my elevon and aileron push rods, and then once that was good, put on my vertical stabilizers, let those glue, you know, let the glue set on those, and then hooked up my my rudder push rods, and I was good to go. Okay, so I think that that's most of the build. I will down below. I will have links to the thread on this airplane on the RC Powers forum. I took a lot of pictures as I went along and wrote up a bit of a sort of step-by-step build log there, so you can go follow along there if there's something, or just please comment down below, and I'll do my best to help you out. Okay, so as I mentioned before, on the info page, the recommended throws are there, and so I would strongly encourage you to read this. Now, one thing that I learned, unfortunately, it got my heart racing, but it didn't. Fortunately, I didn't have any problems with the airplane. The control setup is recommended is 2 inches each way. For the elevon deflection, 1 inch on the aileron and 1 inch on the rudder, with 40% expo all around. Now, I normally fly with 15% expo in the pitch and the roll, so you might want to just adjust that. If you fly with more expo, you like to fly with more expo, then maybe take those up a little bit, or if you fly with less, like I do, maybe take them down a little bit. Just because originally when my first flight, it was super sensitive in the roll, so that kind of got my attention definitely. But after that first flight, I landed it, and then I sort of reduced my throws down quite a bit, and now I've got it dialed in just the way that I want it. So just something that I learned there. I kept. I probably could get away with a little bit more, maybe another 15 or 20% less throw in my elevons in the pitch. But after I got some flights in on it and saw how it reacted and responded, especially in the pitch, I decided to leave a little bit extra in there. I like to leave a little bit of emergency extra pitch throw anyway, just in case I get cocky or I lose focus or something like that. I like to be able to have that extra little bit to keep me from hitting the ground or myself or the fence or something like that. Okay, so let's talk about how it flies. Because it is a rear mount, torque roll on launch it's going to be a factor, probably more than what you might be used to in a prop and slot airplane. And because you don't have any control surfaces in the prop wash, when you first toss it, it doesn't have a whole lot of airflow going over the control surfaces. So you have to be careful with how much throttle and I found anyway, angle that I throw it at. I'm launching mine at about 50% throttle. So with this power setup, that is based on the numbers on the bench, it's about a 1-to-1 thrust to weight ratio. Anything more than that, and I found that torque roll became really aggressive, and then the plane was, I was slapping the sticks around a little bit to get it back upright. What I did find with mine at first, and not as much now, that I've actually shimmed my motor down so it's angled down a bit, and I'll talk a bit more about that. But until I did that, what I found was, I was originally launching it at maybe 40-45 degree angle, and what the plane would do is right after it left my hand, would kind of do one of these things. Maybe because it was a tail mount, maybe because I didn't have my motor aligned properly, I'm not sure, but it did one of these. So of course it's pulling up there, getting close to stall, and I was able to sort of power it. I had enough thrust that I could just kind of nose it over a little bit, and once it got nosed over and leveled off and picked up speed and get some airflow going over the wings and the control surfaces, it was fine. So now I launch it at a bit more shallow angle than what I normally with my prop and slot park jets. I'm probably launching at a 40 to 45 degree angle. I launch this at a bit more shallow angle of attack, maybe about 30 degrees, and again about 50% throttle. And I experimented with sort of anywhere from 40% throttle to 60% throttle on launch. 60% was, I found, was way too much. It really, really, torque rolled as soon as it left my hand. And 40% wasn't enough, because then what would happen is it would, 40% it would sort of sit there and then almost stall, and then I'm, hammering the throttle and hoping that it's going to climb away. So 50% seems to work. 1-to-1 thrust to weight ratio seems to work out really well. And now that I, have 50 flights on it, I know very well what it's going to do. Once I got it flying and once I got it trimmed in, it handles just beautifully. It's very, very, I haven't flown it in any wind, I should caveat that, but I find it flies very, very stable. It tracks, the old saying, it just tracks like it's on rails. It's super, super stable. It goes where you point it, and it stays going there until you point it somewhere else. So it holds its energy, and it holds its attitude very, very well. It doesn't, it's, again, I haven't flown it in any wind, but it's not wandering all over the place. It's really, really locked in. Speed management on this plane is probably a little bit more critical than you might be used to in a prop and slot park jet. So you got to be careful, when you're going into a turn, to make sure that you're taking some decent speed. I find actually, because there's no foam back here behind the prop, that it flies more efficiently than a prop and slot plane. I'm probably flying around. I can fly around and do lots of great turns and rolls, simple aerobatics at just pinning the throttle at about 50%. Whereas with most prop and slot park jets, I'm probably flying at around 60%. So because you don't, because there is, you have to fly it to understand it, but there is a little bit of a delay sometimes in how, especially in the pitch, I find more so than the roll. But I've got ailerons and elevons working together, so I've got lots of control surface moving in the roll. But in the pitch, sometimes you will find maybe a tiny little bit of lag. So you go into a turn, you're going to lose a little bit of speed when you go into a turn anyway. So you want to make sure that you don't go into a turn starting off slow or behind the power curve, so to speak. But it's not. It doesn't go really, really squirrely, but you could get yourself into trouble if you try and get into any turns or start doing any aerobatics with less than optimal speed. Very efficient glide characteristics. It has a very natural sink rate. Because of this, I think because of this, you've got a very large section here along the bottom that's pretty much completely flat. I'm thinking, similar to F-22s, F-15s that I've built in the past, that this is actually providing you with some lift as the plane is flying. So what it does is it makes it feel like the wing is bigger, so it actually feels lighter on the sticks. I have some prop and slot park jets that are the same size as this one, but a couple of ounces lighter, and this plane feels as light or even lighter on the sticks. Now, as I mentioned already in this video, what I was finding was, and I did have my motor maybe out of, pardon me, out of whack a little bit, or again, because of this flat bottom. What I was finding, especially on 4S, was when I would hammer the throttle and the thing was winding out to full speed, is it would start to zoom, just do an uncommanded climb. Not as bad as what I've seen on some planes, but when you really want to be out there and impress your friends and hammer the throttle, you want the plane to, of course, sort of keep its nose buried, stay level, and keep the speed up, because it will tend to sort of slow down as it climbs. So what I ended up doing was I just took some little washers. They're about, I think about a millimeter, 1.2 millimeters thick, and I put them on the top two screws of the motor here. So the motor is angled down now, maybe about 4 to 5 degrees. And that, I haven't tried it on 4-cell since I did that adjustment, but on 3-cell it just beautifully buries the nose and hammers straight ahead. And also, I mentioned before I adjusted the motor, the nose would kind of want to climb away on its own on launch. I don't notice that anywhere near. If I notice it at all, it's considerably reduced now that the motor is angled down a little bit. So if you build one and you find that, don't hesitate to experiment with just angling your motor down just a little bit. Don't go too much. I wouldn't go any more than, say, maybe 4 to 5 degrees down angle at first and see what happens. You don't want to have a situation where you crank it all the way down and you launch it and it goes dunk into the ground. That would be a very bad day, although a very short walk to the walk of shame to the crash site. Yoicks. Okay, so I think that's about it. One last thing I did, of course, in my beautifully organized. Let's grab this bottle here. I build a lot with this premium craft glue, Craft Medley premium craft glue. Fortunately, I can get it at my dollar store. It's identical to Bob Smith Industries foam cure. And what I did here was, because I'm belly landing it, you can see there's lots of dirt. The field's not in the best conditions right now in the wintertime. But I took some scrap foam and I spread a super thin layer of that glue down this very center piece here on the nose and all along here to protect the foam, to keep it from getting ripped up. I've got a couple little gouges in it right here, but especially if you were using a softer foam like maybe MPF or Dollar Tree foam, you'd want to protect it somehow, either doing that or with tape or something like that. Otherwise, you're just going to rip up the bottom of your plane. So, yeah, I can't think of much else. I know this has been long and I've been yakking here for a while. I hope that this has been helpful. I certainly really enjoyed flying this plane. I love how it looks in the air. Obviously, I haven't painted it yet. I wanted to do this walk around because I was going to be handling it with my grubby paws before I put a paint scheme on it. But yeah, I definitely, once you get it up there and flying, other than some subtle differences in, especially in the pitch, I do have to be a little bit more cognizant to feed in, anticipate and feed in the pitch a little bit earlier, when coming out of a dive, or a loop or anything like that. But I haven't run into a situation where I've gone, oh my God, I don't have enough, I don't have enough control. Yeah, I'm very pleased with this plane. It's by FRC Foamies. It's beautiful. I ended up balancing just perfectly on the CG, so I got lucky there, and really enjoying it. So I'm, once I get a paint job on it, looking forward to lots more enjoyable flights. And I'm also thinking already about building another tail-mounted airplane. Probably the FRC Foamies F-22 Raptor, because I also have a soft spot in my heart for the F-22, so I'm going to probably build that. Maybe not this year, maybe, I don't know. Sometimes I'm like a crow, I see a shiny thing and I have to have it or have to do it, so we'll see what happens. So there we go. Please again check out the comments down below. I'll have links to where you can get the plans, the thread to the RC Powers forum, my video on making KF4s, links to all the electronic components that I used, and if you have any questions whatsoever, please don't hesitate to leave me a comment on my YouTube channel. Eventually I will have a blog post on this, which I'll link down below, but that might not happen right away. Or you can get in touch with me through the RC Powers forum or my email address, scott.parkjet@gmail.com. So I appreciate your patience sticking with me through this video. Thanks very much for watching. Blue skies, calm winds to everyone. Park jet noise, the other sound of freedom, baby. Take care.